I just working through part 2. Have you done part 2 yet at all?
No.
Okay. So, that's just what I was going through.
So are you guys doing? Never mind. I answered my own question. This stuff is really confusing now.
Yeah, it's different. I can't believe there's so many ways to post statistics.
That's true.
Right.
Yeah. And my bishop in my singles ward back in Maryland, he's a statistician for his job. That's what he did.
Nice.
I don't know why.
Well, what's wrong with him?
Probably was. He's a
Oh, we could do an experiment on kids' vitamins and what colors they're in. Maybe.
We could. I have vitamins.
See?
Gummy ones.
Yeah,
Oh, yeah.
I was going to get the
Those are the good
Spider-Man ones and the Captain America ones. I don't know.
My daughter actually started vitamins today because she keeps wanting more vitamins. Yeah.
Yes, vitamins.
Not the whole bottle of vitamins.
Well, yeah, that's
Oh, well.
Do we have to come up with something tonight and tell her what we're doing?
Yes.
Did you just want to start on the quiz now, or go over part 2?
We can do whatever you'd like. We can go over part 2 if you want. If there's something on there that you guys have questions on, or we could just start the homework. It's up to you.
not the homework, the quiz.
Yeah, not the homework.
I
Sorry.
thought we'll go into the quiz, but I don't know what you feel like, Steven.
This ain't just homework.
Okay.
Better log in.
If login will start.
You want me to read 3? What do you guys want to do our thing on?
Don't know yet.
So we have to have it turned in tonight?
Yeah, I think,
Well, by Saturday.
Saturday, so we need to talk about it.
Yeah.
Okay.
Tonight or Thursday.
Ideas around. So are we starting in the group meeting quiz now? Or are we gonna do the part two?
Whatever you'd like to do. I opened up the homework or the group meeting thing, but we could go over the second section.
Section 2.
Section, sorry.
Section 2.
Section 2. Yeah. So what would you like to do?
I'm good going to starting on the quiz.
Okay.
Stephen?
I'm good with that.
All right.
All right. Okay, so number 3, in a pie chart, why are the slices sectors different sizes? Okay. Each size represents a category, and the area of each slice represents the proportion of the total divided by the category. I would have to say that's the greatest part, right?
Is that B or D?
I think it's B.
At least on mine's B.
Yeah.
I guess that is the more detailed, yeah.
Portion, it says, pie charts are used when you want to represent the observations as part of a whole, where each slice or sector of the pie, pie chart, represents a proportion or percentage of the whole.
Yeah.
Yeah.
So each slice is different because it represents a different category. Okay, so we all agree with that?
Yes.
Alright, so number 4, how are bar charts and Pareto charts related? They are identical. Pareto charts are constructed from tossing a coin 7 times. I don't think so. The only difference between a bar chart and a Pareto chart is that the bars in the Pareto chart are ordered largest to smallest. That's the right answer.
Yeah, the last one.
Yeah.
But you have to order it that way.
Yes.
Is that what makes it that way?
Yeah, because if you remember, at least on the book reading, you went in, typed elements, and what it did was it just made it go from least to most.
Yeah.
Descending.
Descending. Right.
So.
Okay. We conclude that P hat is normally distributed by if NQ is greater than or equal to 10 and N times 1 minus P is greater than 10. This is P the true proportion of the sample proportion. I'm going to look that up.
Yeah, I'm going to look it up.
P hat is a point estimator for true proportion. Oh, wait. Yeah.
P is a true proportion, and the P with the little arrow is the sample,
Yeah.
right?
True proportion.
In the equation, can you guys hear me?
Barely.
So what about now?
A lot better.
So in that equation, though, does P have to have the hat on it?
There's 2 P's. And the P with the little hat on it would be the sample proportion. And the P without it is the true proportion.
Right.
Does that make sense? Because in these problems, we're working with 2 different P's.
Okay. Thank you.
Okay, what is N?
The sample
It's
size.
it's still a sample size, isn't it?
I would agree, yeah.
The number of candidates in the election. Yeah, could be. Okay, so if P equals 1/4, what is the smallest n that satisfies the requirement? Would that be 4?
I guess. I'm trying to think of what.
Oh, are they looking for a 0.25?
That's what I was saying. You know.
So it would be 0.25?
I don't know. That was a guess.
Well, if P equals the X over the N,
Are they trying to make it so it equals 1? Or
P equals X over N. What is the smallest N that satisfies?
so what's the smallest sample size that satisfies the requirement? So
So we have to take that formula and flip it around.
I guess we would, huh? So if it's 0.25 equals X over N, and so
Or
if we
N
flip it,
times P, because X divided by N.
right?
To get your X alone, you would multiply
by
your N times P. Does that make sense?
Yeah, it does. But what is going to be your answer to
I
that?
don't know.
1/4 equals N times X.
X divided by N.
Okay. Yeah, I'm confused with those.
Let's see if it's in the reading. I'm not recall seeing it. But all I see is that formula. X divided by N equals the P.
Yeah, I don't.
We come back to it.
yeah, let's come back to it later.
I could just be making it more difficult than it is. Wouldn't be the first time.
That's true. So let's go to 8, I guess.
Okay.
Use the following information to answer questions 8 and 9. Suppose n equals 24 and p equals 0.4. What does the mean of p? Would that be 0.4 then? Isn't the mean the population?
That's it. There. So what's the X value?
Our sample's 24 and our P is 4.
Our sample is what?
It's
Sample's
well, it
24.
should be 0.4, correct? Because the mean is P. It's what I got out of the book.
Oh, yeah.
And then for number 9, I got 0.1 if I did my calculation correctly.
And that's the square root.
Yeah, because I did 0.4 times 1 minus 0.4 divided by 24, and then I took the square root of that answer.
Yeah. So the P is the N, or not, P is the mean?
P is the mean, yes.
And you got what, 0.1?
Yeah.
0.1 is for 9, right?
Mm-hmm.
Yeah.
Does someone want to double check that calculation just in case?
Yeah, I can check it. But I'm stuck on 8.
I was looking for the answer for 7. What did you say P was? Or 8?
8 is 0.4. Because
Okay, when is that 0.4?
It's in the reading.
I can look in the reading if you want me to find it.
No, if that's what it is, it's going to be just the same as what the P is.
That the mean is the same as whatever the P is.
Yeah, I was gonna
Okay.
And even if you look at like the number 9 on part 2, it said what's the mean and standard deviation, and it'd be 7% or 0.07 because that's P. And it'll say up in number 9.
Okay, so use the following information to answer questions 10 through 13. Brittany's batting average is .300. We want to determine the probability she will get more than 35 hits in her next 100 at-bats. N equals 100 and P equals 0.3. So which one was that going to there? So what is P hat? Round to 2 decimal places.
Is that the X divided by reading?
So number 11, right?
10.
10. I thought that would just be 0.3 as well because that's what it says for the P.
Right. I agree.
That might be 0.30.
I'm plugging in the standard deviation formula here.
Okay, so 10 would be 0.30.
Yeah.
Okay, so what is the standard deviation of P?
I have 0.050, sorry,
That's at
0.0458.
That's what I've got.
That's what I got. So I put 0.046 because that's 3 decimals.
3 places, yeah. Okay, and the z-score is like the value.
Right. So which is the value?
E. Right, value minus E.
Mm-hmm.
Divided by standard deviation.
Right. Okay, so the standard deviation is 0.0458. I'm going to put all of it in. What is the value? So they want to see if she'll get 35 hits, right? So that's 35, and then the mean would be
100.
would it? Okay. that's not bad. The mean would be 0.3. No, that's not ideal. I don't know if this is in there right.
Going to the homework.
Did you guys get a negative for number 12?
Yeah, it just didn't seem right. Because it was like a negative 1419.21.
I
So
got a
I've got
negative 0.5521.
negative 5521. So what was your value?
Well, that's when I was confused if I was doing it right because I put 0.046 because I wasn't sure if that's what the P there was. Subtract 0.3 divided by 0.46.
Okay, on this p hat, it says that x is divided by n. So I really don't think n is right.
Yeah.
Right, because if that's the case, well, what is x then?
35
Is 35?
divided by 100, right?
Yeah, yeah. So it's
0.035. Now, in our homework, we did something that got us a value.
Yeah.
Was the z-score 1.995? Or am I wrong on that?
No, I'm not sure what it is right now.
I'm guessing. I'm trying to decide what the P with the little hat actually is. Because it says that it's supposed to equal x over n, correct?
Right.
Yeah.
And so what's x? Would that be like a 0.3
Wouldn't it be the 35?
or 35?
That's our sample, right?
Well, the sample is 100.
Right.
Right. So
But the
it's
sample mean,
Probability of 35.
right. So it would be the 35 over the 100.
So x equals the total. Wait, x equals the number of individuals in the sample with the characteristics you're focusing on. So yeah, it would be 35. So it'd be 35 over 100.
hold on a second, someone's at the door. Watch your headphones, Trace.
So that'll be 0.35.
Hi, brother David. You should say hi to the class. Thanks.
Yeah, exactly. All right.
Okay, so, excuse me, in our homework, number D,
Uh-huh. Well, now I'm getting 0.001. If I do the 0.35 subtract 0.3 divided by 0.46.
Why 0.4? Why 0.35?
I got that because if
35 over 100.
the P with the little hat would be 35 over 100.
Okay, so you're classifying that as your value.
Yes.
Okay.
And then I subtracted that from the regular P, which is 0.3, and then I divided it by 0.46, which was the
Okay.
standard deviation.
Yeah, and our z-score comes out a lot better. 1.091.
1.091.
Is that what you're getting on that? Or if we use the 4.6, it's going to be 1.087. So, what's the question trying to ask us here? This one's going to be tricky because your z-score is going to be different.
Okay.
But I guess if you just use the 3 out there,
which is
0.046, then you'll get 1.087. Is that what you got?
Oh, repeat that, because I guess I'm confused at what you're saying.
okay. Let's put the formula in there.
It depends on the standard deviation. If you just round it to 3, it would be different than if you round it to 4 or 5.
Yeah,
So I guess we just go with rounding it to 3.
that's what it says to do.
Okay.
So I guess.
So 1.087. What does that look like in the applet?
1.087.
13%.
14 if you round up.
Yeah. Okay, so that kind of sounds right? Because if she's batting at 30%, and they're thinking that she's going to get 35 hits, normally she gets only 30.
Yeah.
So the probability that she'll get 35 this time is 14%.
But you're rounding to 3 decimals, so it's 0.139. For number 13, right?
Oh, yeah, I didn't get that far, sorry. 0.139, yes.
If we're using that area.
All right, so does that make sense?
Yeah.
Everybody agree with that? Makes sense to me. Of course, it could be wrong.
Steven's battery died on his laptop. Hopefully he's finding a cord. The true proportion of people who support a political candidate is 0.52, and if n equals 2,000 people are surveyed, we want to determine the probability that the results of the survey will suggest the candidate is losing the election, getting less than 50% of votes. What is the standard deviation of p hat?
Awesome.
So that would be 0.52 for the first one.
Yes.
And then now we need to find the z-score.
Yes.
So what would we put for first P in there?
I'm sorry, I didn't hear that, Alyssa.
So for the first one, the P with the little hat,
Yeah.
what would you, I guess, put in there? Would you put, since you're looking, it's not like a specific amount, I guess. It'd be like 49 divided by 100.
Was there a similar question
I'm
like
really
this?
confused. I don't know. I'm
Yeah.
really confused right now. Too many things open, so I can't just go from one to the other to try to find it. So in section 3.2.2 of lesson 16,
Mm-hmm.
The sample portion p hat is normally distributed if n is large. The true population mean of the random variable p hat is p hat equals p. So that makes the 0.52 make sense. Now what z-score would you use? Z-score thing now.
It's right underneath it, but I'm not sure I understand it. Because if you're doing the value minus the mean, which is the p hat minus p, you're zero. So why even do that?
Well, that's why I think there's a we have to make the p hat. That's what I'm thinking. But the x, there's not like a definite amount that they want. They just want less than 50%. So would you put in like a 49?
Oh, okay.
I don't know, because the n is 2,000, so if you're wanting 50%, it would be 1,000, right?
Mm-hmm.
What is the standard deviation? Okay, what's our standard deviation?
Oh, well, the standard deviation that I got is 0.0111.
0.001.
And how did you come up with that?
Well, the standard deviation is the square root of the p.
0.52 times by 1 minus 0.52. Then I divided that by 2,000 and took the square root of the answer.
And you came up with 0.0112?
No, 0.0111. So
0.52, and your sample size was 2,000.
2,000. Yeah, I got 0.01117, so.
but to round it, it would just
0.11.
Yeah, 0.011.
Okay, so that's the value you get. So you'll put that value.
Okay, so I put that value in
I gotta see my formula.
standard deviation.
0.11 minus 0.52, right?
And I guess I'm having a hard time with number 15 because I don't know what the P with the little hat is, the value for that one.
The P with the hat is the 0.011.
Okay.
Oh,
No, that's the standard deviation.
Yeah.
Sorry.
Yeah, so what is your
That's
value?
what I was saying, because if the P with the little hat is X over M, we don't have, and that's why I was saying we don't technically have like a specific number. But
Yes.
should we be putting 49 in? Because if someone gets 49, that's the closest they can have for it to being losing, I guess, without being completely equal. But I don't know, I guess, what we're really...
Well, if we take that, I'm just talking here, I'm not saying it's right. If we take the X over N, then that equals P, but we're given the P value, Do we times the 0.52 times the 2,000? Because that gives us 1,040. Let's see what
I'm
we
going to
see for.
screen share.
Okay.
If I can find the right one here.
Hi, Stephen, you made it back.
I did.
Yeah, just in time.
Oh, we're confused.
Okay, so if we read 3.3.2,
Uh-huh.
this is kind of similar to that question we're asking.
Okay. So we probably should just put the 0.5 in then, that you're saying. Minus.
Right, if they're wanting to get 50%.
Mm-hmm.
Minus the 0.52?
Yeah.
So that is the... Right, yeah, that makes sense.
And divide that by.
So the value is the 0.5. 0.52, and the standard deviation is 0.001.
Yeah.
Did I put that in there?
Negative
See, 1.8018. So 802. Did I put this wrong? Or did I just go too far here?
I got negative 1.790.
I got 1.18.
What's our standard deviation? 0.01. 0.011, right?
Yeah.
So I got negative 1.8181818.
Yeah, that's what I got.
Okay.
So I did 0.5 subtract 0.52, right?
0.52? Yes.
And we divide that by 0.011.
That's what you're sharing.
Yeah, well, that's what I guess I got too, but I guess I got a slightly different number because I used the full number 0.0111711392.
Yeah, that'll give you a different number.
And it did give me a different number.
Yeah. So negative 1.818.
I would say so.
And you want less than?
So 0.1385. Is that the same answer we had about? I do wrong.
So for 16, would it be the first one?
I think so. Less than or equal to Z.
Yeah.
No, it's B.
It is?
Yes.
All right, explain that to me.
I will screen share. I googled it.
Okay.
Hold on. That's what I've been working on. How do I screen share?
I think it might be to your left, and it's a
It's a green arrow,
green arrow. Green box with a white arrow.
and then you select the screen you want to share.
So I didn't select the right script.
Well, you did, but
That one didn't change.
The cumulative probability or cumulative probability.
oh,
Would you agree or disagree?
Huh.
and see what's in the homework.
And I just looked through the homework and I couldn't see it.
Okay.
I I have been wrong before. It's okay if I'm wrong. I can tell.
Once or twice then.
And then 17, I've got .035.
That's what I have as well.
103.
Yeah, that's off the probability app. Do you want me to share that?
That's what I have as
To the
well.
left side.
Yeah.
So,
So 15, what did you get?
15, negative 1.818.
okay, then we need to go back to number 7, right? And decide.
Yes.
You said negative 1.1.8?
No, 1.818.
But isn't that a negative?
Negative 1.818.
You could screen share.
I could.
Tell me that number again, slowly.
We're going to screen share it.
In my brain, that is not registering.
Okay. Can you see that?
Hold on. Can you scroll down a little?
Roll up a little.
Yeah, scroll up.
Is that the right way?
The other way, honey.
Other way. Sorry.
Negative 1.818.
Okay, 7.
All right.
So 7.
P equals.
So when my computer died, it erased my answers.
Oh, lame.
So 11, I have 0.046.
Yes.
And then 12, 1.087.
0.87.
Okay. I don't have 13 at all.
0.139.
And then 14 is 0.011.
Yes.
Okay. You guys agree with 16 or disagree?
You can turn yours in first and tell us if it's right or not.
What did you get for 7?
We're still deciding on 7.
We need to decide on 7.
I'm going to do 0.25.
Okay.
Zero 0.25 is not right.
Neither is 16, huh?
10 is wrong.
10 is
16
wrong.
right.
10 is wrong?
17 is wrong.
17 is?
Yeah.
Huh.
So is 17 bigger?
How can that be wrong?
Maybe it's not just a 1 onto the corner, it's just 1 in the middle one.
Let me look.
Yeah.
So that 0.965,
Uh-huh.
966?
Is that what it rounds to, is 966?
But other ones were wrong, Stephen? Was it just 7?
And 10?
So it was
17.
7, 10, 15, 17.
15 was wrong?
Yes. No. Yes, it is.
15 is wrong.
Negative 1.818 is wrong.
Oh,
It's probably the negative 1.790 then.
I need to make up the 9. It's like,
Well, you
it's a
think
little-
if they tell you to round it, you would use that rounded number for the next.
Right.
1.7 what?
90. And that's a negative?
Well, put it in there.
Negative 1.7.
Or is it a positive?
Mine was negative.
Okay.
Yes. What did you put on number 12? Was it 1.085 or 1.087?
Steven?
What was that?
Oh, what did you put for number 12? Was it 1.085 or 1.087?
1.087.
I don't know. I had a 5 in there.
So, well, if we put in the z-score of 1.790, that's going to change 17. Right?
Yes.
Well, I because number 5 was wrong. It's the sample proportion. And 10's wrong still. And 17 is still wrong.
5 is wrong?
Yeah, it says. You know, no, I must have not clicked that. It's still the true proportion.
Okay.
Apparently, I didn't click it.
7 is still wrong, right?
7's still wrong at 4. 10 is wrong at 0.30. And 17 is wrong at 0.966.
But 15 is right at negative 1.79.
So 17, I had 0.037.
I'll screen share real fast and you can see.
Yeah.
So if you see that,
Yeah, I think 17, because we changed the z-score to the negative point, whatever,
negative,
1.79.
oh, that's true.
I think that's supposed to be this, I don't know if you can still see it, 0.0367, which would be 0.037.
Yeah.
Okay, and 10, we don't know, we don't have a clue what that is going to be.
I'd have to dig through the reading, I think.
For 10?
Yeah, I have no idea.
And 7 is so confusing. If P equals 1/4, what is the smallest n that satisfies the
So you know, it would
requirement?
be 35 divided by,
All right, is this for 10?
yeah. So would that be 35 divided by 100?
I thought that's what we had in there, though.
That means
0.35.
it's 0.35 and I put 0.30.
Oh.
So if one of you haven't turned it in, maybe put 0.35 instead.
Okay, I'll put 0.35. And what are we thinking about 7? What is a different guess than 4 and 0.25?
I have no idea.
1/4.
What is the smallest n that satisfies the requirement? 1?
I'm either thinking maybe 1 or 2 because 2 is divisible by 4. I don't know. Maybe it's 1.
All right, I'm going.
Okay.
I'm tired of playing this game. 7 is inaccurate, but 10 is right at 0.35,
Okay.
and 17 is right at 0.037.
Yay.
So we're narrowing it down.
Right.
That's true.
If we could only do this on the tests.
Wouldn't that be nice?
It would. I don't know.
So. And then, so for our group project, do you just want to think about it over tomorrow and then bring some ideas on Thursday, or?
Yeah, we could email each other.
Okay, we can do that. So,
Okay, and what do we have to do by Saturday on this?
let me just double check over it.
We have to decide what part of it we want to do.
We have to do the design the study. All right?
Okay.
And let me just open that up. I'll screen share it really fast if anybody cares to see it. So we need to list each of our names.
Okay.
We need to decide who the main writer is going to be. And then we all need to collect the data. Then we need a main writer to describe it, one to make inference, and one to take action. Someone needs to do a PowerPoint. And then we each do a group evaluation.
Okay.
Here's some ideas for topics, I guess.
So to start off with, we just put our name there and then design the study.
Yeah.
What
Decide
topic
what we want to do.
come up with so far?
What was that, Stephen?
What have been your ideas so far?
They're talking about colors of cars, Skittles.
That one was a joke.
I think something to do with popcorn, too, right?
Yeah, it's just like the popcorn. Vitamins.
Oh yeah, kids' vitamins.
Kids' vitamins. Something.
Then they have these other ideas too, like Chips Ahoy, paper towels.
I like Oreos.
Our double stuffed Oreos, really double stuffed.
Yeah. I like double stuffed.
Because just data, because I'm eating it.
So,
Okay, well, I'm still looking for the thing. I don't know.
You just have to 100 bucks.
No, I don't, because I suck at everything else, but, you know, I have no idea what it's supposed to be.
we need to do that, and then we need to state a research question. And what populations are you studying, and what are your null and alternative hypotheses? So I guess that's what we need to do this week.
Okay. Sounds like fun.
Alright.
Yeah.
Sounds good?
I'm